Okay, chemistry, diagnostic, very important. These are the things you should remember going to grade 11 chem. Let me just fix my mic a bit. I think this is better. Uh, let's finish fast. Should be 15-20 minutes. 20 minutes at 25 minutes. A certain mass of helium is placed in, okay, blah, blah, blah. They gave us P1, V1, T1. Volume was constant. We know P1, V1 equals nRT1. P2, V2 equals nRT2. We know that volume is constant, N and R are constant, so P1 over P2 is T1 over T2. So in this case, it's going to be P1, which is 120 over T1, over, this is T, قصدي P, P1 over, yeah, this works as well. P1 over P2, which we don't know, equals T1, the first temperature is 25 degrees Celsius. Remember, we have to convert to Kelvin. So plus 273, وهون كمان plus 273. It will be 298 over 398. Cross multiply, 160. Question 2. What is not true about noble gases? أكيد they are monatomic, of course it's true. They are inert and they don't react, it's true. Their melting points and boiling points decrease, لا, it's supposed to be increase. They belong to column 18. That's true. It's true. They are highly reactive. أكيد it's false because noble gases are stable. They don't react. Okay. What is the process at 37 degrees Celsius? أكيد at 37 degrees Celsius, we're going from solid to liquid. It's melting. During a phase change, so when it's changing phases or states, what happens to temperature? We know it remains constant. You can see here, when it's changing states, it's staying constant. Which of the following can be used to describe the value 37 degrees? 37 degrees is the point where solid changes to liquid and liquid changes to solid. Solid changes to liquid, يعني melting point. Liquid changes to solid, يعني freezing point. يعني melting point or freezing point. How long does it take to melt the solid? يعني how long does it take to change from here solid to liquid? 8 minus 2 is 6. So 6 minutes. Remember, two significant figures, so 6.0. Then evaporate, يعني to change from liquid to gas. You go liquid, gas, 22 minus 12, 10 minutes. Question 4. Which of the following is pure? أكيد it's going to be the one that's sharply, not around, you can't say around. The one, again, pure here, it's the one with the straight line, curve B straight. The molecular mass of a compound is 70 AMU. Give its molecular formula. Given that its empirical formula is CH2. Okay. If its molar mass is 70, we know it's CH2. CH2, carbon is 12, hydrogen is 2. 2. So this is 14. What do you do? We know it's supposed to be 70. 70 divided by 14 is 5, right? So that means we have to multiply everything by 5. So it's going to be C5H10. So it was multiplied by 5. Since it's 14 here, it's 70 here. That means you have to multiply by 5. Question 6. RR and GR. Okay, we have this experiment. They told us 14.2 grams of chlorine reacted with sodium. So here we can do RR and GR. What do they want? They first want the moles of chlorine. So before R and GR, we can calculate the moles of chlorine. You know, N equals M over M. So the mass of chlorine, which is 14.2, over the molar mass of chlorine. Remember, it's Cl2, it's diatomic. So 35.5 times 2 is 71. That's the molar mass of chlorine. You're going to get 0.2 to 3 significant figures, 0.200. Now we want the moles of sodium. This is where you do RR and GR. RR and GR. They want the moles of sodium chloride. We go to sodium chloride. Here, NaCl. In the reaction, it's 2. Do we know how much is it given? No, so we put an X. What do we have? What do we know? What we know from previous parts, how much moles of chlorine reacted. And chlorine in the reaction is 1, and in the given, we know that it's 0.2. Can you just cross multiply? Yes, you can. You get 0.4 to 3SF, it's 0.100. Find the mass of sodium chloride. Again, you have to use N equals M over M. We know the moles is 0.4. Mass of NaCl is 35.5 plus 23, which is 58.5. Sorry, what's this shoe mass? Molar, sorry. Equals the mass. We don't know the mass, but we know the molar mass. Big M, it's down, 58.5. So you cross multiply and you get 23.4. Question 7. Okay. 0.5 moles of butane undergoes, okay, butane is C4H10. Okay, find the number of moles of oxygen gas that reacted with 0.5 moles. Again, we have to do RR and GR. What do we have given? We have given 0.5 moles of butane. That's what we know. Start with the given. What do you have given? We know that we have 0.5 moles of butane. In the reaction, how much is it? It's 2, right? What do they want? They want moles of oxygen gas. So you go to O2. We know in the reaction it's 13, but do we know how much is in the given? No, it's always X. Cross multiply, you're gonna get 6.5 times 2, 13, true 13. Divide by 2, yeah, 3.25. Find the volume of oxygen at RDP, you know, as well as M over M, and equals also V over Vm. Since it's RTP, you know that RTP equals 24. Vm equals 24 at RTP. We know that the moles is 3.25. We're trying to find the volume. How about Vm? We know that Vm is 24. It's given in the question. Since it's RTP, you cross multiply, you get 78 to 3SF, 78.0. Air is 20% oxygen gas. Find the volume of air needed of the given sample to react completely. Okay, remember the way I told you. Since it's 20%, you always do 100 divided by the percentage, okay, times your volume. Okay, it's 20. So 100 divided by 20 times the volume, 78. 100 divided by 20 is 5, so 5 times 78, you get 390. Question 8. Aluminium reacts with oxygen to produce Al2O3. Okay, a sample of 108 kilograms of aluminium is reacted with excess oxygen to produce aluminum oxide. Find the number of moles of aluminium in the given sample. Okay, to find moles, we do N equals M over M. The mass is 108 kilograms. But you know, in chemistry, we don't use kilograms, we use grams. So it's going to be 108,000 grams. Divided by the molar mass of aluminium is 27. Once you divide them, you're going to get 4,000. It's 4,000 moles. Calculate the number of moles of oxygen gas consumed by the reaction. Now, we want something completely different, right? Let me rewrite the reaction over here on the side. 4Al plus 3O2 to produce 2Al2O3. We know that RR and GR. Okay, what do we have given? We have given that the moles of aluminium is 4,000, right? 4,000. Okay, how much is it in the reaction? It's 4. ماشي. نحن what do we want? We want oxygen gas. So we go to oxygen gas. In the reaction, we know it's 3. طب how about in the GR? We know it's always X. You cross multiply and you're going to get 3,000. Calculate the mass in kilograms of oxygen gas. أكيد we do N equals M over M. The moles of oxygen here 3,000. The mass, we don't know it, but we know that the molar mass of oxygen is 32. At this point in grade 11, you all should know that O2 is 32. 16 times 2. You should have it memorized. No, هيك على السريع على الطاير. M, you cross multiply, you're gonna get it's 96,000 grams. وهنا they want it in kilograms, so you divide by 1,000, it will be 96. To 4SF, 96.00. Give the name of the solid extracted by filtration. So the thing that stays up. You have filtration, right? This is the funnel or whatever. The thing that stays up is the filtrate. It's what got filtered. Or the thing that stays, my fault. هيك. The solid that stayed up here is what we call the residue. Residue, in English, the definition of the word residue means what's left behind. So this is what's left behind in the funnel. Then what went down is obviously the liquid, which is the filtrate. Okay? Choose a type of solid liquid mixture that can be separated. أكيد any heterogeneous mixture. Homogeneous mixtures cannot be separated using filtration. Heterogeneous mixture means a mixture, a solid, that has a liquid. Heterogeneous mixture is one that has a liquid and solid particles that are not able to dissolve, so they can easily be filtered through a filter paper. Locate the apparatus required for filtration. أكيد you're gonna need a funnel, you're gonna need filter paper, of course, or conical flask, or if they put for your beaker, I guess that would work, but no, conical flask would be preferred. Choose the heavier gas. The last time this came in a CA last year, it was wrong. The question had a mistake in it. Here, which one is the heavier gas? أكيد the one with the lower rate of diffusion, so gas X. Find the molecular mass for gas X. For this question, you do V1 over V2 equal radical M2 over M1. I think I've solved this question on my channel now 8 times. V1 over V2, always start with the faster one. So 0.87 over 0.63 equals radical M2. The mass of the 0.63, we know it's X, right? Over the mass of this 0.87. Remember, mass 2, V2, mass 1, V1. They're across from each other. It's not V1 or it's not M1 over M2, it's M2 over M1. So M2 is X because 0.63. Now M1 will be the mass of this 0.87, which is hydrogen chloride, which is 36.5, because H equals 1 and Cl is 35.5. Hydrogen chloride is HCl. Okay, so it's going to be 36.5. Now you can just input this into a calculator. You can do 0.87 over 0.63. You put alpha equal radical, you have x تحت بتحط 36.5 shift solve x, you get 69.6. Then drag and drop in increasing order of rate of diffusion. By the way, if you don't have a calculator that can solve equations, square both sides. Okay, then whatever you square this on the calculator and you get a fraction, then that fraction just multiply it by 36.5. Drag and drop in increasing order rate of diffusion. So the slowest one, and this is the fastest one, obviously the slowest one will be the heaviest one. CO2 is 44, the molar mass. HCl is 36.5. I won't calculate them for you. You should know how to add up molar mass. H2O is 18. So the fastest one will be the lightest one, which is the least molar mass, so H2O. Then second least will be HCl. Then third least will be CO2. Choose the phenomena responsible for the two separate gases to collide. These gases, they collide. The phenomena is diffusion. Which one's the lighter gas? The lighter gas, always, the color will appear on the side of the heavier gas. Okay? It's going to appear closer to the heavier gas because the heavier gas took time to move. Okay? So since it appeared closer to B, that means B is the heavier gas. That means the lighter gas will be gas A. How long is this? 12. Okay, I think I finished before 20. What is the molar concentration, okay, of 1 dm cube, in which 0.5 moles? Okay, let's put it. The triangle, C equals N over V. Okay, C equals N over V. So the moles is 0.5. The volume is 1. 0.5 divided by 1. 0.50 is the concentration. How many moles? N equals CV, right? So N equals CV. So concentration 0.5 times the volume 0.1, 0.05. They want 2 SF, so add another 0 at the end. Then volume V equals N over C. The moles 0.1, concentration 0.2. You get 0.50 to two significant figures. Yes. As student wants to prepare, they gave you volume in cm cube, concentration, find the mass. Okay, أول شيء to find the mass you need the moles, right? You need the moles. And we know that the moles is N equals CV. But be careful, they gave it in cm cube. We need it in dm cube. To convert to dm cube from centimeter cube, you divide by 1000. So it will become 0.1 dm cube. So my N will be 0.1 times 0.1, which is 0.01. Okay, this is my moles. هلا, can I find the mass? Now I know the moles. Yes, N equals M over M. Okay, find the mass of sodium carbonate. Sodium carbonate is Na2CO3, which is given here in the question. Can we find the molar mass? Yes. Na2 will be 46 plus CO3, 48, 60. It will be 108 or 106. Na2, 46 plus 60. Yeah, it will be 106 is the molar mass of Na2CO3. So the moles 0.01 equals the mass over the molar mass 106. You cross multiply 1.06 gram. Question 12. The mass number of an element indicates the number of protons and neutrons in its atom. أكيد the mass number, protons and neutrons. Okay, which one has a 2, 1x? This one means 1 proton, and how many neutrons? 2 minus 1 will be 1 neutron. So 1 proton, 1 neutron, this one. Question 13. You have these bonds. Okay, how do you do it? Let's see. You have 4 CH bonds. So 4 times. Remember, you do the reactants minus the products, yeah? 4 times CH 413. Plus you have this carbon double bond, 6O2. plus ClCl, which is 240. Okay, and then you have 1, 2, 3, 4, 4 CH bonds again, 4 times 413. You have the CCl, 2 CCl bonds, which is 2 times 327. And then you have the CC bond in the middle, which is 3, 4, 6. So then you do this 4 times 413 plus 602 plus 240 minus 4 times 413 plus 2 times 327 plus 346. Hold up. Wait, hold up. Go back. Oh shit. Take. Okay, yeah. 2494 minus 4 times 413 plus 2 times 327 plus 346, close bracket. Yeah, minus 158. Remember to put it in brackets. They want 4 SF, so put 0.0. Question 14. Okay, which one? Okay, you have to choose the rate thing. Okay, the original curve is which one? Oh, no, they didn't give us an original curve. Okay, which one has a lower temperature? Okay, a lower temperature, the the final product will still be the same. Why? Because we didn't change the concentration of the limiting, right? Remember, you only have less or more product when you change the concentration of the limiting. Everything else only affects the steepness of the curve, so it only affects the rate of the curve, which is the steepness of the curve. A lower temperature will still give you the same product, but it will just be a bit slower, so it will be less steep, right? So it will be curve B. A lower concentration of hydrochloric acid. Here they said that the excess is calcium carbonate, and if the calcium carbonate is the excess, then the hydrochloric acid will be the limiting. So if they gave us a lower concentration of hydrochloric acid, which means a lower concentration of the limiting, and after we will have less product, so it will be C. Using lumps rather than powdered. Okay, lumps. Okay, now we started with powdered. Lumps are bigger pieces. Bigger pieces. So instead of having powder, which with a huge surface area, now we change into lumps. Lumps are bigger pieces, meaning they have a less surface area. That means the rate will decrease, so it will be less steep. So it will be B. The addition of the catalyst, speeds up the reaction, right? So it will be curve A. Curve A for the catalyst. Okay, how many molecules are present in 2.5 grams of NO2? Okay, أول شيء the number of molecules equals n times Avogadro's number, n times NE. N is equal to the mass divided by the molar mass, which is 2.5, divided by the molar mass of NO2, which is N14 plus 32 is 46. Okay, which is equal to 2.5 divided by 46. Yeah, okay, 5. What was it? 5 over 92. Then 5 over 92, we want to multiply by Avogadro's number NA. So times 6.0 times 10 to the power of 23 times 6 times 10 to the power of 23. You get 3. To two significant figures, 3.3 times 10 to the power of 22 molecules. Question 16. A sample of O2 contains 9 times 10 to 21. How many moles does it contain? Okay, we know molecules is equal to N times Na. Can we find the moles? Of course we can. The moles will just be equal to the molecules divided by Na, right? So in this case, the molecule is 9 times 10 to the power of 21 divided by Na, which we know is 6 times 10 to the power of 23. And you're going to get 1.5 times 10 to the power of negative 2. How many grams does it contain? We have the moles, we have the molar mass, it's O2. So we can find the mass. N equals M over M. The moles, 1.5 times 10 to the negative 2. The mass, unknown. The molar mass is 32 because it's O2. You cross multiply and you get 0.48 grams. Question 17. Choose the diagrams that represent atoms. Why aren't these? My fault. Atoms are supposed to be neutral. Okay, so if it's an atom, that means it's neutral. So P and E 1 they cancel, so it's neutral. This neutrons don't count. P and E cancel out, neutral. P, there's no electron to cancel it out, so it's not an atom. Okay, it's an ion, it's a positive ion. Here, P, but two E's, so it's more negative, so it's a negative ion. Here, P, P, E, E, they cancel each other out, so it's correct. So A, B, and E are my atoms. The positive ions will be C. The positive ion will be, let me erase. The positive ion will be C because it's the only one that has more protons than electrons. And then D will be the negative ion because it has more electrons than protons. Question 18. Okay, here, same thing. P1 changed to P2, V1 changed to V2, T1 changed to T2. So everything's pretty much changing. But we know P1 V1 equals nRT1, P2 V2 equals nRT2. R with R and with N because he didn't mention mass over R at all. So we know P1 V1 over P2 V2 equals T1 over T2. P1 V1 over P2 V2 equals T1 over T2. Pressure 1, 50. Volume 1, 6 over T1. Remember to convert to Kelvin. It will be 400. No, will it be 400? No, it won't be 400. 273 plus 177. Akid, it should be, it will be 450. Yeah, 450. 450 و 627 هلا plus 273 هيدي 900. Okay, T2 is 900. Oh, and why am I putting the sorry why am I putting the temperature here? P1 V1 the temperature هون 450 over 900. Sorry, P2 V2 would be the second pressure 100 times V2. We don't know it, so let's start calculating. 50 times 6, let's cancel these to make things easier, these zeros. Okay, I'm gonna get 5 times 6 times 90. 5 times 6 times 90, 2700 equals 45 times 10, 450 obviously, V2. So V2 will just be 2700 divided by 450, which is 6 to 3SF, 6.00 dm cube. Yalla, almost done. It will be 25 minutes. Yes. A sample of 0.0444. Okay, exerts a pressure. So mass, temperature, volume, R, we want P. So we have everything. So we're gonna use PV equals nRT. We're gonna use the equation of the gas equation. The pressure unknown. El volume 3 moles. Moles, it's hydrogen. So N equals M over M. The mass 0.044. The molar mass H2 is 2, is 1 0.044. It's gonna be 0.022 times 0.08, which is R, times the temperature 57 plus 273, 280, 330. Okay, let's do this now. 330 times the moles I just got times 0.08 divided by 3, 0.1936 to 3SF, it will be 0.194. And for our last question for today, they left the longest for the last. Okay, a solution prepared by adding, this is the volume, okay, 0.1 moles of sodium sulfate, and this is the volume, 0.2 moles NaCl2. Okay, they want concentration of all ions. Remember, whenever dealing with these types of questions, the first step is to write the dissociation reaction of each one. So Na2SO4, we know dissociates to Na plus SO4, 2 minus. Let's balance it. We need to put 2 here. Now it's balanced. For the second one, ZnCl2 dissociates to form Zn2 plus and Cl minus. But this to balance the Cl, we have to put 2 here. Now, we put the moles for each one. We have 0.1 moles of Na2SO4, right? Now we check. If it's the same coefficient, you keep the moles the same. If it's a different coefficient, like 2 here, you multiply the coefficient by the moles. 2 times 0.1, 0.2. هون same coefficient, so you just keep it as 0.1. Same here, ZnCl2 0.2 moles. This is the same coefficient, so 0.2, but this is the coefficient is 2, so you multiply 2 by 0.2, you get 0.4. Okay, now we have the moles. هنا بدهم الconcentrations. C equals N over V total, because you're mixing two solutions, 50 plus 150. So the total is 200 centimeter cube. But you know that we can't deal with volumes in cm cube, it has to be dm cube. So you divide by 1000, it will be 0.2 dm cube. For over 0.2, it will be N over 0.2. Let's start with the concentration of sodium, Na. Na 0.2, right, is the moles. So 0.2 is the moles over V total is 0.2. It will be 1.0 as a concentration. Na. هلا concentration of SO4 2 minus the moles of SO4 2 minus, which is 0.1 over V total is 0.2. You're gonna get 0.50 molar concentration. Concentration of Zn2 plus, the moles of Zn2 plus, which is 0.2 divided by V total is 0.2, you're gonna get 1.0 molar concentration. The concentration of Cl minus, you have the moles of Cl minus, which is 0.4 divided by the V total, which is 0.2, you get 2.0 molar. يعطيكم العافية. Good luck everybody in the periodic. Thank you so much for watching.